Hello everyone, Mr. Minix, my name. Math is my game. And what I'd like to do here is take a look at some Chapter 6 items. Just tie up some loose ends. 6.3, 6.5. Um, I think 6.3 is the empirical rule section. We'll talk about that here in a minute. So what I did is I just have my Math Excel open. I'm going to go ahead and look at that, and we'll see if there's a couple things we need to make note of. I'd like to give a shout out to the future Mr. Minnick. I'd like to give a shout out to my 4th and 6th period stats class. And so let's see. Homework 6.3. Looks like I already did part of it. This was that one. It's a pretty tough assignment, I'm not going to lie. So yeah, this empirical rule. I'll go ahead and talk about that. The empirical rule really talks about this normal curve. And it would probably be best if I just got a picture of this on the internet. Standard normal curve. Standard normal curve. Images. So go ahead and try to cut that out and take a look at that. So the standard normal curve, this one's actually got the percentages. I don't know how well those show up. But remember, the mean is right in the middle. The mean is in the middle of this thing. So what this empirical rule says is this, that if you go one standard deviation below the mean, in other words, mu minus sigma, okay? If you go one standard deviation above the mean, in other words, x plus sigma, that in that interval, in that region, that 68% of the data in the population would reside in that interval. Okay, if we extend out to 2 standard deviations, so we go, that's supposed to say mu plus, so anyway, if we go to mu plus 2 sigma and to mu minus 2 sigma, in that particular zone, in that region under the curve, that 95% of the data would lie in there. 95% of the data would lie in there. Okay. If we go one step further to 3, to x plus 3 sigma and x minus 3 sigma, to those intervals, so if we look at all that region, that 99.7% of the data would lie in that region. Okay. If that's 99.7, then if you think about the extreme ends, that leaves 0.3% to be split up here and here. So in other words, anything beyond 3 standard deviations below is actually I guess it's 0.15%, and anything above would be 0.15%. Okay, so 0.15%, that's not very likely, and that's, if you remember right, we had those outlier tests. Okay, so let's go back to this. So for any data set having a roughly bell-shaped, approximately 68% of the data is going to be within 1 standard deviation of the mean, and 95% is going to be within 2 standard deviations, and 99.7 is going to be within 3 standard deviations. Okay, so that's going to be the same every single time. Bell-shaped, 68, 95, 99.7. Okay. All right, if we move on to the next item in homework 6.3, what they're asking us for here, and I'll just redo this one. A variable is normally distributed with a mean of 15 and a standard deviation of 2. So they're saying, what's the percentage of all possible values that lie between 12 and 17? Okay, that lie between 12 and 17. So I'm going to get my calculator out for this one. So what I'm going to have to do here, I think I'm going to have to calculate some z-scores. I think I'm going to have to calculate some z-scores. If 12 is the low end of the interval, the z-score for 12 would be 12 minus 15 over 2. So that's negative 1.5. The z-score for 17 would be 12 minus 17. No, I'm sorry. 17 minus 15 over 2, which is 1. Okay. So now what I'm going to do is I'm going to go to my table, and I'm going to look at the area under the curve to the left of negative 1.5 for the z-score, and that's 0.06681. 0.06681. So I am using the table, okay? Then the z-score of 1, I go there, and I get 0.84134, 0.84134, 0.84134. And I'll take the difference of those two, and that ought to do what I need it to do for this first part, if my calculator works. So 0.84134 minus 0.06681, I get 0.77453. So 0.77453. Now they want this as a percent, and they asked me to round to 2 places, so that's going to be 77.45%. Okay? And it says, good job, well done, because I know what I'm doing. Yay! All right. So the next one, it says the percentage of all possible values that exceed 10. So that's to the right of 10. So what I want to do on this one is find a z-score of 10. So a z-score of 10 is going to be 10 minus 15 over 2, which is negative 5 over 2, or negative 2.5. So let me go to the table. The z-score for negative 2.5 is 0.00621. 0.00621. That's not the z-score, I'm sorry, that's the area, 0.00621. Okay? So that's my area to the left of that. But I want the area to the right of that. So I need to use the complement, or go 1 minus 0.00621. And when I do that, I get 0.99379, and let's see what that's going to be. As a percent, that's going to be 99.38%. 99.38%. And we'll check that, and there we go. Okay? So there is another way I could have done that, and if you know it, good. If you don't, well, ask me, and I'll tell you. So this last one here, this last one's just going to be straight up find the z-score, and then we'll go to the table. Okay, the percentage of all possible values less than 13. So again, here we're finding a z-score. Z-score for 13 would be 13 minus 15 over 2, which is negative 2 over 2, which is negative 1. In my table, the area to the left of negative 1 is 0.15866. 0.15866. So I just need to make that a percent then. So that's going to be 15.87. I believe it's 15.87. And there it is. Okay? So really, we haven't seen much new other than that business about the 68, 95, 99.7. Okay? If we go on to number 3, this one gets into quartiles. So let's try this one. Okay, let's see what's going on. This says, let's find the first quartile. So in other words, let's find everything that's to the left of the lower 25%. So what we need to do here in this one is somehow find everything to the left of the lower 25%. How are we going to find that lower quartile? The lowest 25%. Well, if I go in my table, and if I look in the table for an area of 0.25, the closest I get is negative 0.67. Okay, negative 0.67. So the z-score that corresponds to 25% to the left of that it's actually negative 0.67. Okay, so that's my z-score. Now what I got to do here then to find this quartile, to find the quartiles, I'm going to make a substitution. I'm going to replace the z-score. So I'm using this formula, z equals x minus mu over sigma. So I'm going to plug in negative 0.67 equals, the x-score is going to be my quartile that I'm looking for, so that'll be the variable x, minus mu, so minus 14 over 2. Okay, and I'm going to go ahead and solve that equation, and I do that all in one step. So negative 0.67 times 2, and whatever I get there, I'm going to go ahead and add 14 to that. And so I get 12.66. So that's my lower quartile, 12.66. Okay. Now it's not going to let me move on until I find the next one. So the second quartile is everything below 50%. So if I find the z-score that goes to that, the z-score that goes to that is actually 0. Okay. So the z-score that goes with 50% of the stuff to the left of it, that z-score is 0. So for part B here, I'm going to have 0 equals x minus 14 over 2. So I'll have 0 times 2 plus 14. So there I get 14. I don't need to round that one. Okay, don't need to round that one. Now for this third part, what I need to do is find the 0.75 area, find the z-score that goes with 0.75. So if I go to 0.75, the z-score that matches up with that should be positive something. And it's actually 0.67. 0.67. So here I'm going to have 0.67 equals x minus 14 over 2. So again, it'll be just like that one a few minutes ago, just with a positive 0.67 instead of a negative 0.67. So here I should get 15.34. 15.34. And there we go. Okay. So that was a little bit of work, but that's what it takes. It's 6.3. It's no joke. It's probably one of the toughest sections we'll see. 85th percentile. They're asking us, okay, we need to find the z-score for something that has 85% of the data to the left of it. So the z-score that has that, if I go to my table, I'm looking for 0.85, and the z-score that matches up to that is 1.04. So the z-score is 1.04. So again, z equals x minus mu over sigma. So 1.04 equals x minus 14 over 2. So again, to solve this, I'll take the 1.04 times 2 plus 14, and I get 16.08. 16.08. 16.08. Okay. Now, let's keep in mind what a quartile is. A quartile splits the lower 85% from the upper 15%. So it divides the bottom 85% from the top 15%. Okay. So now we want the 65th quartile. So I find the z-score that goes to 0.65, and that is, looks like 0.39. It looks like 0.39. So 0.39 times 2 plus 14. 14.78 ought to do it. 14.78. 14.78. Okay, maybe I used the wrong z-score. 65. Come on. Maybe I'll try 0.38. 0.38 times 2 plus 14. 14.76. Let's try it again. 14.76. Uh-oh. The value that 65% of the possible values exceed. Oh! Oh, they want the inverse of this. I'm looking at this the wrong way. They don't want the 65th percentile. They want to know the value that 65% exceed. So they actually want the 35th percentile. They want the 35th percentile. So I'm actually going to look for the z-score that goes to 0.35. The z-score that goes for an area of 0.35. Z-score that goes for an area of 0.35. It's going to be negative something. And it should be that negative 0.39. Let's see. 0.35. Yeah, it's the negative 0.39. Okay? It's the negative 0.39. So negative 0.39 times 2 plus 14. So it should be 13.22. Should be 13.22. I was looking at that the wrong way. Remember, I might have said it before, a picture is worth 1,000 words. Okay? A picture is worth 1,000 words. So the two values that divide the area under the curve in the middle, 95%, and the two areas outside to blah, 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 blah are. So this is kind of like that one before we had seen this. They're saying, okay, 95% here in the middle. So if we take 95 divided by 2, that's 47 and a half. Well, actually, what did they say then? So I guess that leaves what, 2.5% below and 2.5% above. So I guess I need to find the z-scores for each of these. Yeah, with an area of 0.025. So I need to find the z-score for that. And the z-score for the other is going to be positive that. So let's see, 0.025. 0.025 is negative 1.96. So that z-score is negative 1.96. The other z-score is going to be positive 1.96. And I want those two values. So here's what I'll do on this one. On this one, I'm going to use all that other stuff. So negative 1.96 times 2 plus 14. So I'll get 10.08. 10.08. And then I'll redo that entry, this time with a positive z-score. I get 17.92. There we go. So this 6.3, I hope you can see, it's no joke. It is no joke. Not impossible, but the calculations, it's pretty intense. So basically, we're just dealing with percentiles. We're finding z-scores and that kind of thing. Okay. So I think what I'm going to do now is I'm going to go ahead and get out of 6.3, and I'm going to go into 6.5. So we'll try to get into 6.5 here. There is a Chapter 6 test out there. I wouldn't suggest trying that yet. 6.5, I hope it's a little easier. Why should you sometimes use a normal curve to approximate binomial probabilities? I'm thinking it has something to do with trial sizes. It's not practical to use the binomial formula when trial size is very large. Lucky guess. Maybe I did my homework before. All right, so this 6.3, let's see. A student is taking a true-false exam with 10 questions, blah, blah, blah. Um, more with the normal table. The probability that the student gets 6 or 7 answers correct. Ooh. So somehow they want us to mix the normal distribution in with this. So this is going back to the binomial formula. Oh, that might be fun. I'm going to skip over that for now. Yeah, I might have to do my homework and get back to you on this one. So throughout the week, you'll be working on 6.3, wrapping that up. 6.5, as information becomes available, I will hook you up with that. Look also out for a test later on this week. We'll review for that likely on Thursday. So that's it. It's been real. It's been fun. Have a great day. Bye.